Number 18, we want to solve this one by factoring. We're going to use our zero factor property, and really this one's already factored. And the zero factor property says if I have two things being multiplied and equal 0, either the first thing, which in this case is the x minus 6, equals 0, or the second thing, the 4x plus 1 equals 0. So the x minus 6 would equal 0, or the 4x plus 1 would equal 0. And now I just solve each. For this first one, I add the 6 to each side. So I find out that x equals a 6. That's one of my answers. And then for the second piece, I would subtract the 1 from each side, which gives me a 4x equals a negative 1. And then divide each side by the 4. So I'd find out that x equals a negative 1/4. Okay, so those are my two solutions for this particular problem. For the next one, I do the same thing. I've got two things being multiplied. So either the first piece, the 3/4 x, equals 0, or the second piece, the 6 minus 2x, equals 0. Okay, that's what my zero factor property says. And now I solve each. For the first one, I can multiply each side by a 4. It's probably the way most of you are going to approach this. Over here, the 4's cancel out, so I'm left with the 3x equals 0. And now I divide each side by the 3, so I find out that x equals 0. So that's one of my answers. My other answer, I'm going to subtract the 6 from each side. Let me put a little space in between those, which is going to give me a negative 2x equals a negative 6, and then divide each side by the negative 2. So I find out that x equals a positive 3. So those are my two answers. In number 20, in order to use my zero factor property, the thing has to be set equal to 0 before I can factor. So I need this set equal to 0, so I'm going to subtract the 7x from each side. So that's going to give me an x squared minus 7x equals 0. And now I solve by factoring. For this one, I can factor out an x, which leaves me with an x minus 7. And now I set each factor equal to 0, so either the x equals 0 or the x minus 7 equals 0. And I solve each. The first one, the x equals 0, is already solved for x. The second piece, I just add the 7 to each side, and I find out that x equals a 7. Okay, so my two answers are the 0 and the 7. In number 21, it's already set equal to 0, so my zero factor property, I've got it equal to 0 now, I just need to factor. I build a bridge, that's a positive 8. Two numbers that multiply to positive 8 but add to a negative 6 are a negative 4 and a negative 2. And for this one, I can use my shortcut for factoring because I have a 1 out front. Remember, when I have a 1 out front, I can go right to the answers and do an x minus 4 times an x minus 2. And now I can use my zero factor property, which says either the first piece equals 0 or the second piece equals 0. And now I solve each. This one I add the 4 to each side, so I end up finding out that x equals a 4. For the next one, I'm going to add a 2 to each side, so I find out that x equals 2. And those are my two answers. For the next one, once again, I start off the same way. I'm going to build a bridge. That gives me a negative 18. The two numbers that multiply to negative 18 but add to a positive 7 are a positive 9 and a negative 2. And for this one, I can't use my shortcut, so I have to split up the middle term. So I've split up the middle term. I get a 3x squared plus 9x minus 2x minus 6 equals 0. And now I have to factor by grouping. So I group the first two together, group the second two together. Out of the first two terms, I can factor out a 3x, which leaves me with an x plus 3. Out of the second two terms, I can factor out a negative 2, which leaves me with an x plus 3. So now my two factors are the x plus 3 times the 3x minus 2. This equals 0, and now my zero factor property comes into play. I set each factor equal to 0. And now I'm going to solve each. So this first one, I'm going to subtract the 3 from each side. So that gives me x equals a negative 3. The next one, I'm going to add the 2 to each side, which leaves me with a 3x equals 2. And now I divide each side by the 3. And I'm just going to leave this as a fraction, as x equals 2/3. Okay? For this last one, The first thing I want to do is always take care of the greatest common factor. And in this case, instead of having to just factor out the greatest common factor since it's a constant term, since it's an equation, I could just divide each side by 5. And when I do that, that leaves me with an x squared minus 4 equals 0. Well, now x squared minus 4 is a difference of squares, which means it's going to factor into conjugates, x plus 2 and x minus 2. And now I set each factor equal to 0 using my zero factor property, and I solve each. Subtract the 2 from each side. I find out that x equals a negative 2. Here I add the 2 to each side, and I find out that x equals 2. And that's it. All right. The other way to approach this one, I'll do it again, is if I had the x squared minus 4 equals 0. If I solved for x this way, I could add the 4 to each side, and that would give me an x squared equals 4. And now I could take the square root of each side. But remember, when I take the square root of each side of an equation, I have to leave it as plus or minus that root, which is plus or minus 2, which counts for the positive 2 and the negative 2. Okay? For the next one, again, I'm solving it by factoring. With this one, I can factor out a greatest common factor of 3x, which leaves me with an x minus 3. And now I set each factor equal to 0, either the 3x equals 0 or the x minus 3 equals 0, and I solve each. This first one I divide each side by the 3, so I find out that x equals a 0. The next one I add 3 to each side, so I find out that x equals 3. And that's it. And number 25, again, I build a bridge. So I build a bridge that gives me a positive 2. The two numbers are a 2 and a 1. This one I can use my shortcut for, so it factors into x plus 2 and an x plus 1. And now I can set each factor equal to 0, the x plus 2 equals 0, or the x plus 1 equals 0, and I solve each. So once again, I'm subtracting the 2 from each side here, so I find out that x equals a negative 2. For this one, I'm subtracting a 1 from each side to get x equals a negative 1. And then the last one here for this one, x squared plus 16 is not a difference of squares because there's a plus sign in between here. If it was a difference of squares, that would have to be a minus sign. So I can't factor that into x plus 4 and x minus 4 because that doesn't work. If I put a 0 in for the middle term and build a bridge, that doesn't work. This one can't be factored. So the only way to try to solve this would be to subtract the 16 from each side, which gives me an x squared equals a negative 16, and then try taking the square root of each side, which I can't take the square root of a negative, so this one is no solution.